In this demonstration we're just going to show you how to use the Reaxys program to search for the structures of molecules. So open up a browser at the university which you believe will have support features for JavaScript. So we'll probably recommend this Reaxys in Mozilla or the Google Chrome, and then you see this page here. We can start searching in reactions or substances or literature. So I think on this one, if we just want to search for a molecule structure, we press on substance or substances, and then in the structure editor bar, if you click on that, there's a few features, kind of program systems to draw the molecules in. So we'll just leave it as default on structure editor, and we see this system here. So bit like ISIS or ChemDraw here, with various functionalities on the top bar and the sidebar to look at drawing organic molecules. So we'll draw something from myself in Jim Wilkinson's illustrious career, synthetic career. We're just going to clip in here a system, maybe like a diaryl methyl ring, and then we'll look at searching for the methoxy substitution. So we'll click on this at that point as well. So we'll transfer the query across. So we're looking for this diaryl methane system, this methoxy position. We'll transfer the query over at this point, and then we'll look, and we'll look to take the molecule as drawn. So as substances, and if you look down here as well, you've got tick boxes you can include for various structural changes to the system. So we'll just look at this system as drawn and see what it comes up as. So we'll look at the start search substances box. We'll click on that, and we find the 6 hits. So it should lead us into the next screen. And you look down and you see, so for example, here's the molecule of choice, and you can hold the mouse over various features that Reaxys gives you. So this gives you an availability in terms of how to buy this from the catalogue. So we'll maybe look at that as well in a few moments. And it says show corresponding substances, or maybe just click on this show details. So this gives you the name of the molecule and its identification data. So here's some journals of which it's listed in, and then we'll just click away from that. And then you've got pattern information here, maybe physical data if you wanted to look at melting point data, it's listed, boiling point data at atmospheric pressures, reduced pressures, refractive index, chromatography information. You scroll down, I'm sure you can see what we're up to here. And then spectral data as well. So if we wanted to identify the molecule through spectral data, we'll just click on that and see what happens. Yeah, we've got identification is this Australian Journal of Chemistry. So all the information of the system is in place. So I'm just giving you a quick 5-minute introduction or recap of Reaxys here. But what I would say is that just get on it and give it a good kind of a play as such. The other things just to look at as well could be, let's say, spectral data. We've just clicked on that, so we've got the NMR data as we've just identified. So look at the NMR data as listed, infrared data, the journals, mass spec, UV. So we'll go to the top here, so we'll click on that and return back to the top. And yeah, so as well with Reaxys as well, it might give you this kind of tab here. So how do we make this molecule? So we can press on this and it gives you the routes of synthesis by manually or autoplan. So we'll just click on maybe by autoplan, and this gives a suggested synthetic tree for this operation. So you can show here you could possibly do this by clipping this borane derivative and the benzyl chloride together to form this structure, and then you can keep clicking on these kind of trees as such to go back, or to give you more synthetic routes into the system. So we'll close that off, and we'll just go back to the synthesis. So we'll click on hide. I think that's better. Well, no, let's move back to query. substances again. And then so we're looking around here. So this as well gives you this reaction in terms of its preps and its reactions. So 64 preps or 86 reactions. So we can use this molecule here as a starting molecule in 64 reactions. So you can see how this system here, how the reaction can form the molecule in 64 reactions. So we'll just go back to this, or in 86 reactions how it's used as a starting material. We'll click on that and then you move down and see how this material is used as a starting material. I'm just going to go back to the query. Like I said to you, very quick video demonstration this, so I do encourage you to get onto Reaxys and kind of play with it and look at things that you want to get into your heart. But let's just go back to the edit structure, and let's just say, again, this is something myself and Jim Wilkinson have made in the past. Let's say we want to look at this kind of system. So just to show you here, you can change the bond to a straight bond, so that's unknown stereochemistry. So like, we don't want a double bond there, we want a single bond, so we'll put that in place. We'll make this a double, so we'll erase that off actually. We want a double bond system here as an allyl group. It's done it again, so we'll delete that off there. So transfer query, back in place. Let's search substances again, and this time let's just go into the search data and let's see if there's any information now for a molecule with bioactivity. So no results found. So if you wanted to click on that tab, shows you about how many molecules might be searched for with biological activity. That's where you would find it. So let's go say spectroscopic data. Can we find anything possibly with an alpha D? So it's not in spectroscopic data. Let's look at physical data. Nope. So can we find anything with an optical rotation? So we'll show details on there, and then we go to spectral issues. Have we got anything in place? So just quickly looking around this, and we don't find anything with potential stereocenters associated to give alpha D data. So we'll just go back onto the substances and see, maybe this one obviously showing a defined stereochemistry. So look at identification here. Again, it kind of lists our papers, myself and Jim. So we'll click on this. So we'll click on this molecule, and again we find out information, our data there. Okay, so I encourage you to kind of look and play around on this system. Just very quickly while we're on it, and this is a very short demonstration, there's many more features to tell you about here. Let's look at as well about this, and can we possibly do any searches, any literature searches. So let's just say, can we search for an author here? So the author contains, let's say it's John Hadfield. So can we search for any papers by Hadfield? So we'll put that in, and we'll possibly then say John. And we'll see what we might get. Search literature, and it gives us at the moment 53 hits. So can we trace our colleague John Hadfield on this? So we've got statins developments. So we've got John Hadfield and McGowan and Chiara and Nick Lawrence and the rest. So we find our colleague John Hadfield here in patent data. So if you go back to the query page as well, you can search as well in terms of literature values. So we'll just move back into this. So we don't want to search for an author now. Maybe we want to search for a chiral lithium amide. Let's see what that gives us. So chiral lithium amide keywords, and we'll search that on the data as well, and we find 77 hits with papers here. So yeah, if you wanted to look for specific words, then obviously you've got your values listed here. Just one other thing while we're on this about searching for literature, again this has been said to you as well. If you go to Web of Knowledge, which is at Mimus, yeah, if you go to Web of Knowledge on that page, then what have we got down here? Then we can search as well on the Web of Knowledge pages. And so again, if I wanted to go for chiral lithium amide bases, what do we find at that point? We find 77 on the previous search engine on Reaxys. We've got 39 papers listed here. So I'm going to stop now. You have been shown information like this in the pharmaceutical science module, but as a quick recap, how to kind of use Reaxys, how to kind of as well use Web of Science too. Okay, thank you.